In this video, we're going to do a little review of exponents, some things that you should already know about exponents, and then we're going to move on to the properties of exponents. All right, so let's start off with a little bit of review. Exponents allow us to repeatedly multiply by the same number. For example, 5 to the third power means to do 5 times 5 times 5. Okay, 5 to the third right here, this is written in what is known as exponential form. Okay, 5 to the third is an exponential form. And then the way that we've just written it here, 5 times 5 times 5, this is called the expanded form. Okay, we expanded it to mean 5 times 5 times 5. And now when we do the multiplication, that gives us 125. And this is known as the evaluated form. Okay, so depending on how they want it in exponential, expanded, or evaluated form, you're going to write this in 3 different ways. Now, this 5 right here is what we call the base. The base is the number or expression that's used as a factor in repeated multiplication. The 3 right there is the exponent, and the exponent tells you how many times to use the base as a factor. All right, now you've had lots of work with exponents in the past. Most of the time you've worked with positive bases, but what if you have a negative base? Well, when you have a negative number as your base, you need to think about whether your answer will be positive or if it will be negative. Here we have negative 2 to the first power, which means I just have one copy of the number negative 2, which means it equals negative 2. There's really no math to do there. Negative 2 to the second power, or negative 2 squared, means to do negative 2 times negative 2. A negative times a negative is a positive, so this comes out to be positive 4. Negative 2 to the third power, or negative 2 cubed, means to do negative 2 times negative 2 times negative 2. And we just saw negative 2 times negative 2 was 4. 4 times negative 2 gives us negative 8. Negative 2 to the fourth means negative 2 times negative 2 times negative 2 times negative 2. We just did negative 2 to the third power. That was negative 8. So negative 8 times negative 2 gives us 16. And then negative 2 to the fifth power. That's negative 2 times negative 2 times negative 2 times negative 2 times negative 2. 5 copies of the number negative 2. And we just said negative 2 to the fourth was 16, so this is 16 times negative 2, which is negative 32. And hopefully you're seeing a pattern as you go along here, okay? If you have a negative number raised to an even power, so like right here or right here, our answer in each case was positive. A negative number raised to an even exponent will give you a positive result. But a negative exponent raised to an odd power will give you a negative result. When we raised the negative number to the first power, to the third power, and to the fifth power, the answer was negative in each of those cases. All right. One other thing that you need to notice about having a negative base, all right, each time that you raise a negative number to an exponent, you need to use parentheses. Notice that in each of these examples above, I had the number negative 2 written in parentheses. Forgetting the parentheses can lead to an incorrect answer, okay? So in example 2, these look similar to each other, but they're actually very different things. When the negative number is inside the parentheses like this, all right, well, it's similar to what you did up here. It's just repeated multiplication. So negative 5 in parentheses to the second power, that just means to do negative 5 times negative 5, which gives us an answer of 25. But when negative 5 isn't in parentheses and then we're using the exponent, it means something completely different, all right? This negative symbol on the outside right here is really the number negative 1, and this means to do negative 1 times 5 squared. All right, so negative 1 times 5 squared, if I do the order of operations, I've got to do the exponent first. So this is going to be negative 1 times 25, which means we get an answer of negative 25 here. These are not going to give you the same answer. So if your base is negative, make sure that you put it in parentheses. In examples 1 through 4, we're going to rewrite each expression in exponential notation. Okay, right now it looks like repeated multiplication. In each case, we'll rewrite it using an exponent. So in number 1, we have 4 times 4 times 4 times 4 times 4 times 4. The base is 4, and there were 6 copies, so that would be 4 to the 6th power. Number 2, we have negative 8 times negative 8 times negative 8 times negative 8. Our base is a negative number, so we have to put it in parentheses. It's negative 8, and since there were 4 copies, we'll raise it to the 4th power. R times R times R times R, the base was R to the 4th power since we were multiplying 4 R's together. 2 times X times X times Y times Y. All right, well, there's really nothing we can do with that 2. X times X is X squared, and Y times Y is Y squared. So this becomes 2X squared, Y squared. Underneath of that, we're going to evaluate each expression. So we want to know what the answer is. So we should first figure out what each expression represents. Notice in number 5, negative 4 to the 2nd power, but negative 4 isn't in parentheses. So this negative right here is really the number negative 1, and we're multiplying it by 4 squared. So that's what that means, negative 1 times 4 squared, which means if we do order of operations, we square 4. So this is negative 1 times 16, which gives us negative 16 as an answer. Number 6, our negative number is in parentheses, so this is going to be repeated multiplication. It's negative 5 times negative 5, which gives us an answer of positive 25. Number 7, again, our negative number isn't in parentheses, so this is the number negative 1, and it's multiplying 8 cubed. All right, well, 8 cubed, 8 times 8 times 8 is 512, so this is negative 1 times 512, which gives us an answer of negative 512. Number 8, negative 9 cubed, negative 9 is in parentheses, so this is repeated multiplication, negative 9 times negative 9 times negative 9, and that gives us negative 729 as our result. Number 9, negative 2 to the 4th power, not in parentheses, so this means negative 1 times 2 to the 4th, and 2 to the 4th is 16, so this is negative 1 times 16, which gives us negative 16. Number 10, negative 1 to the 4th power, negative 1's in parentheses, so it is repeated multiplication, negative 1 times negative 1 times negative 1 times negative 1, and all of that equals positive 1. In example number 3, we're going to complete each of the charts that we see below. Let's see if we notice any patterns. 2 to the 4th expanded is 2 times 2 times 2 times 2, which equals 16. 2 to the 3rd power is 2 times 2 times 2, which is 8. 2 squared is 2 times 2, which is 4. 2 to the 1st is just the number 2, so it equals 2. But 2 to the 0, we can't expand it. But if we notice a pattern here, we will be able to evaluate it. So if we look here, every time my exponent went down by 1, my previous answer, I had to divide it by 2. 16 divided by 2 is 8. 8 divided by 2 is 4. 4 divided by 2 is 2. So if I continue that pattern here, 2 divided by 2, 2 to the 0 power equals 1. All right, with my base of 5. 5 to the 4th power. 5 times 5 times 5 times 5. That's 625. 5 cubed is 5 times 5 times 5, which is 125. 5 squared, 5 times 5 is 25. 5 to the 1st is just the number 5, so it equals 5. And again, 5 to the 0, we can't expand it. But again, if we notice our pattern, every time we decreased our exponent by 1, we took our previous answer and we divided it by 5. 625 divided by 5 is 125. 125 divided by 5 is 25. 25 divided by 5 is 5. So if we continue that pattern here, 5 divided by 5 is 1. And hopefully, again, that you're noticing something here. Any number that's raised to the 1st power, 2 to the 1st, 5 to the 1st, well, we got 2 to the 1st was 2, 5 to the 1st was 5. Any number raised to the 1st power is equal to itself. So 8 to the 1st is going to be equal to 8. Any number raised to the 0 power, 2 to the 0 equals 1, 5 to the 0 equals 1. Any number raised to the 0 power is equal to 1. So 9 to the 0 power will also be equal to 1. Now that we've had a good review of exponents, we are ready to study the exponent properties. There are other special properties that relate to exponents that we will now investigate, and we'll start off with a simple one. We're going to be multiplying numbers that have the same base. So in this example, we have 2 to the third power times 2 to the second power, 2 cubed times 2 squared. We want to rewrite this with the base of 2, but with a single exponent. So the first thing that we're going to do is rewrite each of those in expanded form. 2 to the third means to do 2 times 2 times 2, and 2 squared means to do 2 times 2. So if we look at the original expression, 2 cubed times 2 squared, well expanded, that again, 2 cubed is 2 times 2 times 2, times 2 squared is 2 times 2. How could we rewrite this as 2 with a single exponent? Well, again, our base is 2, and we're multiplying 1, 2, 3, 4, 5 copies of the number 2 together. And hopefully you notice something here. 2 to the third times 2 to the second is 2 to the fifth power. The base stayed the same, and all I did was take these exponents and I added them together. 3 plus 2 is 5. This is exponent property number 1. When you multiply two expressions and they have the same base, keep the base and you will add the exponents together. So x to the a power times x to the b power, since the bases are the same, I'm going to keep it, and then I'm just going to add the exponents together, a plus b. Will this property work if the bases are different? All right, well, 5 squared is 5 times 5, which is 25. 2 cubed is 2 times 2 times 2, which is 8. And 25 times 8 is 200. All right, is that equal to if I did 5 times 2, which is 10, and added the exponents, 3 plus 2 is 5? Well, 10 to the fifth power is actually 100,000, and 200 is not equal to 100,000. So does this work if the bases are different? No. All right. This property only works when the bases are the same. Now that we've learned exponent property number one, let's apply it now to some practice problems. Okay, so again, if the bases are the same and you're multiplying, you keep the base and you add the exponents together. Y to the seventh times y to the fourth, bases are the same, it's multiplication, so I'm going to keep the base y, and 7 plus 4 is 11, so we get y to the 11th power. 1/2 to the third power times 1/2. Now remember, this 1/2 is the same as 1/2 to the first power. So the bases are the same, so I'm going to keep the base of 1/2, and then I'm going to add the exponents. 3 plus 1 is 4, so we get 1/2 to the fourth power. X to the third times y to the fourth times x to the fifth times y to the second. Well, remember, we're only going to work with the ones that have the same basis. So we're going to have x to the third times x to the fifth. That's going to be x to the eighth power. And y to the fourth times y to the second is going to be y to the sixth power. So we get x to the eighth times y to the sixth as our answer. In example D, we have negative 8 to the fifth times negative 8 to the third. Our base is the same, so we're going to keep it. And since it's negative, put it in parentheses. And then add the exponents. 5 plus 3 is 8. So we get negative 8 to the 8th power. 5 to the negative 7th times 5 to the 9th power. Keep the base. And since it's multiplication, add the exponents. Negative 7 plus 9 is 2. So we get 5 to the 2nd power. A to the third times b to the fifth times a to the negative second times b to the negative eighth. Again, multiply the bases that are the same first. A to the third times a to the negative second is a to the first, which is just a. And then b to the fifth times b to the negative eighth is going to be b to the negative third power. 5 minus 8 is negative 3, so we get a times b to the negative third, or a to the first times b to the negative third. The second exponent property we're going to investigate is when we raise a power to another power. In this expression, we have 2 squared, and we're going to take that and raise that to the third power. 2 squared to the third power. How would we rewrite this as 2 with just a single exponent? All right, so the first thing we're going to do is rewrite our expression in expanded form. To cube something means to multiply it by itself 3 times. So I'm going to multiply 2 squared by itself 3 times. 2 squared times 2 squared times 2 squared. All right, and now I can rewrite this as an expression with a single exponent. This is a multiplication problem and the bases are the same, so I'm going to keep the base and I'm going to add the exponents together. 2 plus 2 plus 2 is 6. So 2 to the second power raised to the third power is equal to 2 to the sixth power. What do you notice? Well, hopefully you noticed all you had to do was keep that base of 2, and then you multiplied these. 2 times 3 is 6. We multiplied the exponents. We multiplied the exponents. All right, and so this is exponent property number 2. If you're raising a power to a power, you keep the base and you multiply the exponents together. So x to the a power raised to the b power, we're going to keep the base of x and we're going to multiply the exponents a times b. All right, power to a power, keep the base, multiply the exponents. Let's go ahead and practice using exponent property number 2 when we're raising a power to a power. 5 to the 7th power to the 9th power. I'm going to keep the base of 5, and I'm going to multiply the exponents. 7 times 9, we get 5 to the 63rd power. Negative 8 to the 5th power, raised to the 3rd power. Keep the base of negative 8, so it needs to be in parentheses, and then multiply the exponents. We get negative 8 to the 15th power. 1/3 raised to the 8th power, then raised to the 3rd power. Keep the base of 1/3 and multiply the exponents. So we're going to get 1/3 to the 24th power. Letter D, x to the negative 3rd power raised to the negative 7th power. Keep the base of x, multiply the exponents. Negative 3 times negative 7, we get x to the 21st power. In this example, we have 2 different bases, all right, and we're going to raise them all to the 6th power. So this is x squared times y, which is the same as y to the first. Raise each of them to the 6th power. So we'll start with the x. X to the second to the 6th, 2 times 6, we would get x to the 12th power. And now for the y to the first to the 6th, that's going to be y to the 6th power. 1 times 6 is 6. So we end up with x to the 12th times y to the 6th power. Similarly, a to the 3rd times b to the negative 2nd, all of that is being raised to the 4th power. So start with the a to the 3rd to the 4th, 3 times 4, that's a to the 12th. Now do the b base, b to the negative 2nd to the 4th, negative 2 times 4 is negative 8. So we get a to the 12th times b to the negative 8th power. All right, so keep the base the same and just multiply the exponents together. Our third exponent property involves dividing numbers with the same base. If we have the expression 3 to the 5th power divided by 3 to the 2nd power, how can we rewrite this as 3 with just a single exponent? Okay, well, the first thing we're going to do is rewrite this in expanded form. So 3 to the 5th power divided by 3 to the 2nd power, the numerator becomes 3 times 3 times 3 times 3 times 3, and the denominator becomes 3 times 3. Okay, well, remember that any number divided by itself is equal to 1. So we're going to simplify as many common factors of 3 from the numerator and denominator as we can. So this 3 divided by this 3 equals 1. This 3 divided by this 3 equals 1. And now my denominator is just a 1. 1 times 1 is 1. My numerator, though, I still have 3 times 3 times 3, which is 3 to the 3rd power. And 3 to the 3rd power divided by 1 is just going to be 3 to the 3rd power. So 3 to the 5th divided by 3 to the second is 3 to the third. What do you notice? Well, hopefully you notice that the base stayed the same, and all we had to do with the exponents is subtract them. 5 minus 2 is 3. We subtracted the exponents this time. Okay, so if you're dividing two numbers that have the same base, we are going to keep the base and we are going to subtract the exponents. So let's go ahead and state property number 3. When you divide expressions and they have the same base, you keep that base and you will subtract the exponents. All right, so x to the a power divided by x to the b power. The bases are the same, so we're going to keep it, and then we're going to subtract the exponents a minus b. All right, so let's go ahead and practice that underneath. 9 to the 7th divided by 9 to the 3rd. Bases are the same, so we'll keep 9, and then we subtract the exponents. 7 minus 3 is 4, so we get 9 to the 4th power. Letter B, 3 to the 2nd divided by 3 to the 8th. Keep the base of 3. Subtract the exponents. 2 minus 8 is negative 6, so we get 3 to the negative 6th power. N to the 7th divided by n to the 4th. Keep the base of n. 7 minus 4 is 3, so we get n cubed. X to the 4th divided by x to the 5th. Keep the same base of x. 4 minus 5 is negative 1, x to the negative 1st power. Letter E, 8 to the 7th divided by 8 to the 7th. Well, the base is the same, so we'll keep it. 7 minus 7 is 0, so we get 8 to the 0, and we know that that equals 1. And that makes sense because anything divided by itself is equal to 1. X to the 4th divided by x to the 4th. Again, keep the base of x. 4 minus 4 is 0. X to the 0, again, is going to be equal to 1. 5 to the 3rd divided by 5 to the 2nd. Keep the base of 5. 3 minus 2 is 1, so we get 5 to the 1st, which is just 5. And then in letter H, w to the 5th divided by w to the 4th. Keep the base of w. 5 minus 4 is 1. W to the 1st, which is just w. All right. Now, examples E and F, these two examples right here, they help to reinforce that any non-zero base raised to the 0 power is always equal to 1. Again, we subtracted the exponents, and our exponent became 0, and anything to the 0 power is 1. Anything divided by itself is equal to 1. Examples G and H right here help to reinforce that any base raised to the 1st power is equal to itself. All right, when we subtracted the exponents in each case, we got 5 to the 1st, which is just 5, w to the 1st, which is just w. All right, and then in two of the examples above, we had an exponent that was negative. Here we ended up with 3 to the negative 6th power, here x to the negative 1st power. We will study negative exponents in another lesson, okay? But for this example, for this video, all right, if you're multiplying two numbers with the same base, keep the base, add the exponents. If you're raising a power to a power, keep the base, multiply the exponents. But if you're dividing with the same base, like in these examples here, keep the base and subtract the exponents.